Thank you for reminding me. Okay. Do you see the whiteboard now or no?
Yes.
Yes. Yes. Okay. So in the test, I the only thing I want is, can you copy the matrix associated with this? You and your Geogebra, you solving. So, when you put this arrow and you put R, R, E, F, I understand very well. Yes, echelon 4, no? And finally, the interpretation of this. Okay, let's do it. Let's do it. Let's move on to the Geogebra now. Okay, Geogebra now. Geogebra now. Here. Geogebra now. Do you see Geogebra?
Yes.
Yeah. Okay. I remember in the editor, it's a spreadsheet. You type in the number 1, -1, 3, -2. It's my first row. My second is 2, 0, 1, and 1. Okay. What means yes, Ivan? 1, 5, 1, 26. Okay, 26, 2, 6. Okay, you select everything. Selection. What happened again? The mouse? No. Selection 1. Okay, let me try another way. Selection. Right click. Create a matrix. Okay, and this is the matrix M1. And you put it here in the cast bar. Reduce it, reduce it, reduce it, reduce it, reduce it. Echelon 4 of the matrix N1. N1. Press enter. It's the answer. Okay, I want to copy this answer on the whiteboard. Let me try. On the whiteboard, we have 1, 0, 0, 0, 0, 1, 0, 5, and 0, 0, 1, 1. Okay. So both guys.
You're not on the whiteboard yet, sir.
We switch it to that.
Yeah, it's still showing the Geogebra. Hi, Professor.
Yeah. There you go. Okay. I just
There you
copy
go.
it.
We see it.
Now, interpretation this. I need help. Interpretation of this. We have one solution, infinity many solution, or no solution. What do you think?
One solution.
Absolutely. Why? Because you see clear like a water, the famous identity matrix of the dimension 3. This is I3. Christian label. This is X column, this is Y column, this is Z column, this is the right hand side. Entonces X is equal something, Y is equal something, and Z is equal something. Help me, guys. What is the value for X, Y, and Z in this case?
0, 5, 1.
0, 5. Understand? This is the answer, like the option D in the handout. Any question? Any question? No problema. Okay, super. Let's move on to the problem 11 now. May I erase the board or no? Yes.
Yes.
Boom. I did that. 11. 11 is 5x plus 1y equal. And this is my first equation. My second equation is 2x minus y plus c, sorry, minus w equal 3. Equation 2. My last equation is c plus w. C plus w equal 7. Equation 3. This is my system. It consists of only 3 equations. But we have 4 unknown. So what is the category of this system? Is overdetermined, underdetermined, or determined?
Underdetermined.
Undetermined. Yep.
Under means que is you have no total info underdetermined because we have no total information. That when you have more unknown than equation, it's because you are lack of information, no? Entonces we expect in this case one solution, infinity many solution, or no solution. What do you think? What do you think?
Probably no.
Probably no. Okay, probably no. Or it's possible infinity many solution also or no?
Yeah, because you can have free variables.
And unique is possible or impossible? Unique solution, only one. It's possible or impossible?
Impossible. There's never one solution.
Exactly, never.
All right.
Impossible. Impossible, only one solution. This is completely impossible. Okay. So let's write the matrix associated with the system. Phi 1 0 0, no? Because we have no C. So this column is the X, this is the column of the Y, C and W. In the right hand side we have 1. 2, -1, +1, and -1. And this is 0, no X, no Y. And the last equation, 1 in C and 1 in W on the right hand side. By the way, this matrix is the dimension is 3 by 5. No? Let me see 1, 3 equation. 3. The number of rows represent always the number of the equation, and 5 is the number of the unknown plus 1, is the right hand side. It's the right hand side. One more time, you apply RREF. Do you understand the last day we discussed in Kramer rule? You say, no, professor, I like Kramer rule. But you see reduced row echelon form is super powerful because you can detect in any cases. Do you see one example here in Kramer rule after now, in which you can see it fail the Kramer rule. Sometimes no, it's good. So let's move on again to the Geogebra. Okay, moving on to Geogebra. Boom. Switching the screen to Geogebra. Okay. Which Geogebra now. And my system is 5, 1. Do you see Geogebra, right? 0, 0. Do you see or no? 1.
Yes, sir. It's up.
That's it. Yes, sir. We see it.
Okay. 2, -1, 1, -1. And in the right hand side we have 3. Okay. The last equation is 0. Okay, 0 again. 1, 1, 1, and 7. Okay. Let me try to select. I can do, we use the mouse now. Oh no, but no. Something making mistake in the last number. Okay, there you go. Right click. Select create. Select matrix. Okay, M2. Again, the same procedure. Reduce the row echelon of the matrix M2. Press enter. Boom. Wow, what the hell? Okay, this is the answer. I need to copy in the whiteboard and interpretation this. Let me try. Switching to the whiteboard. Switching. Wait a sec. Here, switching to the whiteboard. Wait a sec. Okay, switching. Whiteboard here. Good. Okay. I suppose you see whiteboard now or no?
Yes, sir.
Yes, sir, we do.
Okay, so we have this situation. 1, 0, 0, negative 2 over 7 is a fraction. Minus 3 over 7. 0, 1, 0, 10 over 7. And 22 over 7. And the last equation is 0, 0, 1. Wait. 1 and 1 here. And 7 here. Okay. Interpretation that. You see.
There's a clear matrix for the first three.
Uh-huh.
And so what, W would be a free variable? I'm not sure.
Absolutely.
Is that what that means?
Absolutely perfect. You can see clear the identity matrix dimension 3, and the variable involved inside the identity matrix is the variable that is not free. The only extra column is W, is free. The only guy that is free is W, and immediately you understand that free variable represents infinity many solution. No? Okay, so the infinity many solution is a little bit complicated to express it, the solution set, because it's not 1, 2, 3, 4, 5. It's the points that belong to the 1, 2, 3, 4 dimension, x, comma, y, comma, c, comma, w, is the space dimension 4, okay, is Einstein space. Einstein define x, comma, y, comma, c, comma, t, que t is the time, pero this is theoretical, such that, and you copy one by one the equation. So you try to express the equation that states the relationship between the non-free variable and free variable. It's obvious that the first one is x equal, you solve for x, this one is minus 3 over 7 plus 2 over 7w. Okay, because w multiplied by negative 2. And when you move to the other side in order to isolate the x, become positive, no? And y is equal negative positive 22 over 7 minus 10 over 7 w is this guy. And finally, z is 7 minus w. Because this one comes to the right hand side like a minus 1, no? And w is free. W is free, que es sinónimo to say all random. All random. See, I try to use my imagination to understand this solution. This solution belongs to the 4-dimension space. It's super impossible to imagination because the only space we can imagine geometric is 3D. 4D is impossible. It's possible in weird way, suppose in weird way like that. And the objective solution, set solution, represent a line. How do you know, professor? It's a line and no a hyperplane. It's a line. It's a line because we have only one free verb. Dimension 1, the line. Plane, dimension 2. A surface, like that, is dimension 3. But in this case, no, it's dimension 1 because we have only one free verb. Yes, no. This represents geometrically dimension of the solution set. Okay? Any question? Do you understand very well the interpretation of the reduced row echelon? Si es infinity many solutions, si es one solution or no solution, and when the equation disappear because the elimination process detecting que es depending, okay, it's just zero, no? 0, 0, 0, 0. This equation is nothing. Okay. This is super fantastic, guy. This is the professional way to face the problem for the system of equation. Nobody using the classical elimination and substitution in college algebra. Okay, let's move on to number 12. Number 12 is determinant wish. Let me try to find the handout. What I have in my well, okay, in the computer. Okay. Maybe you would that. Boom, I have that. We are doing question 12. Question 12 is computer determinant. Okay. Determinant 3 by 3. 1, 2, or negative 2, sorry. Negative 2, 4, negative 1, negative 3, 5, 5. Computer. We can do by hand or we can do by Geogebra. Okay? We can do by Geogebra. In this case, you see the whiteboard or no? Yes or no?
Yes, sir.
Okay. Let me switch it then to the Geogebra. Okay, let's solve it by gain time. 12 and 13 is the same stupid thing, right? It's 13 is 3, 0, 9, 6, 4. Noise, please, putting off microphone.
Sorry, Professor, my phone's acting up. I apologize.
It's okay.
I mean, my computer's acting up.
That's okay. Wow, it's a lie. It's a lie. It's the camera and the light. Okay, no problem. I am in the whiteboard. You told me you see the whiteboard, right? And
Yes.
equation 7, 9, and 8, right? This is 13 is interesting doing by hand because I take advantage of the 0, but this is not. This is crazy. No, crazy. It's possible, but it's consuming time. Now let's move on to Geogebra. Let's do solving both simultaneously because it's the same idea. Okay, I am in Geogebra now. Boom. Okay, there you go. Let me type in. The first matrix is 1, 1, negative 2. Negative 2 again. 4, and negative 1. Negative 3, 5, 5. Okay. Let's do the 13 also. Is 3, 0, 0. is 9, 6, 4. Okay. 7, 9, and 8. Okay, perfect. Now let me try. I select the matrix of the number 12 problem. Let me select. Right click. No. Right click on this. Right click. Carajo. Again, the same problem. Okay, wait a sec. Let me try again. Okay, right click. Create matrix. The name is M3, no? Good. But in the cast part, you put determinant. Determinant. Okay, determinant of the matrix M3. And determinant, give me numbers. 34. That's the answer. They correspond with the option B in the handout. Likewise, or similarly, selection this. Wait a second. Selection this. Selection this. Selection this. Okay. Right click. Create matrix. M4. Now in the cast, you put determinant. Determinant. Determinant, I spelling wrong. Determinant. M4. M4. Boom. And the answer is 36, like the option B again. Let me try. So the answer, I switch into the whiteboard now. Okay. And the whiteboard. Look at that. Here. Whiteboard.
We don't see the whiteboard yet. Oh,
Yeah,
there it is.
you see now. I have some delay to switch in one screen to another screen. The answer was 34, no? 34, and the answer was 36. Entonces I say que, by curiosity, this is out of the game.
They were both negative, sir.
Say again?
They were both negative.
Negative. No,
I
negative.
thought it said negative 34, negative 6. I might be wrong. Okay.
No. Let me check it. Just in case. Maybe you're right. No, it's positive.
Okay.
Joyce.
Yeah.
This is the arrow. This is one big,
Oh.
a little arrow indicating.
Okay. Thank you.
I suppose indicate result.
No, okay. Thank you.
No, it's okay. Okay. Do you see whiteboard? Okay, it's the most important, right?
Yeah, I see it. Thank you.
Now let me check it just in case. The 13 problem. Suppose que some students expand the determinant using the row 1. Get this row. So the first number 3 multiplication by the cofactor. Okay, in this position the cofactor is positive, and this is negative, and this is positive. But this is positive, so the cofactor, remember, is the positive of the minor formed by this determinant. When you delete row 1 and column 1. So this determinant is 6498. So you multiplication, boom, positive. And multiplication, this boom, negative. So this is open parenthesis 48, no? 48. 6 times 8, 48, positive. Minus 36. Que es 9 times 4, 36. And 48 minus 36 is 12, no? 48 minus 36, let me check it when the calculator is 12. And 12 times 3 is 36. In this case, I take advantage, do it by hand, because the rest of the entry is 0 and 0. Entonces I take advantage to compare by. Suppose we have super big determinant. And you take advantage of the 0 to compute by hand. But this is just curious. Let me copy now 14. 14 is another determinant, no? Yes, it's another determinant, right? And the answer is 1, 2, 3, 255, and 1, 2, 3 again. Wow, repetition. You see that the row 1 and the row 3 are identical. So what is the answer of the one determinant that have the same row or the same column? What is the answer? What is the answer? You don't remember?
One solution? No.
No.
I can't remember.
Remember, we compute a determinant, and determinant is a number. 20, 30, 40, negative 5. The answer is a number, no solution. Because this is not a system, it's compute only the determinant like a mathematical object. So I don't know if you remember or no, one property is when you have two rows or two columns exactly the same, well, something interesting happened. Okay, I have no idea. I don't remember, Professor, no problem. Let me try to compute it in Geogebra and you generalize after that. I have no idea. Oh, okay, no problem. I move on to this. So it's 1, 1, 2, 3, no? 1, 2, 3. And the other column is 255. 255. And here repetition 1, 2, 3. No? 1, 2, 3. Okay, now surprise. Let me try to select the element, right click, create matrix. Create matrix. Okay, boom, M5. Again, determinant, M5. Determinant.
0.
0. 0, coño. Wait a second, I forgot. M5.
I'm right now. Are you on?
Oh.
Okay, sorry.
Sorry. I am exciting. Entonces I move into the screen, but I don't switch it. Okay, entonces switching to Geogebra. But the only thing I did is just typing the number. Okay, create a matrix is M5. And in the cast, I put in the row number 5, determine M5, and the answer is 0. And verification, guys. This is a property number something. I don't remember the number of the property, but when you have one determinant in which property 3, okay, in which you have two rows or two columns exactly the same, and not necessarily exactly the same. Proportional maybe is good. Suppose I change for another number because proportional. Proportional means multiplication by no? Suppose que I multiply the row 3 by 2. So actually it's not 1, 2, 3. It's 2, 4, and 6. The answer stays the same. Proportional or it's same. Okay. The answer is 0. 0. You can anticipate the answer 0 because we have the same. The row 1 and row 3 is the same. When the two row or two is the same, the answer is always 0. Any question? No?
On the test, if there was a question like this on the test, would you want us to write out property 3 is it 0 because of property 3, row 1 and 3 are the same?
Yes, either way.
Okay.
I said either way. This is more elegant.
I mean, I could just write 0, but so you know that I knew why it was 0.
Well, maybe you are doing it that way. You don't realize at the beginning it's 0. You put in GeoGebra 0. What? Well, why is 0? They satisfy some special property. And you check it out. Oh, see, the row 1 and row 3 is the same. It's obvious, yes. Okay? Okay, guys?
Yes, sir. Got it.
Now let's move on to the question 15. The question 15 is long, stupid long. Is solving the system of equation using Kramer rule. And the system is 5x plus 9c equal 52. This is my first equation. My second equation is minus 6x plus 3y minus az equal 42. And finally, 2x minus 6y equal negative 40 equation. And they want Kramer rule. Kramer rule, remember, we need to organization the problem in that way. Look, let me show you. You copy now, capital D. The determinant format only for the coefficients in front of the variable. This determinant obviously is 3 by 3. So we have 9 numbers. 5, 9, 0. No, mistake. 5, 0. Because y is missing in the first equation, 9. Negative 6, 3, negative 8, 2, negative 6, and 0. That was capital D. Now dx, I need to compute dx, dy, and dc. This is Kramer rule, guy, using just determinant. And in this problem is determinant system, and the number of variable is 3. Therefore, any determinant is 3 by 3. 3 by 3, 3 by 3, 3 by 3, and 3 by 3. And remember, the idea for the Kramer is replace the column corresponding with the specific variable. This is x, y, z. In this case, dx is you replace the column of the x by the right-hand side number 52, negative 42, and negative 40. And the rest stays the same. The column for the dy, you replace the column, so they stay the same. This is 5, negative 6, 2, stay the same. Now we have 52 here in the y column, 52, negative 42, and negative 14. And the C column, no, stay the same. 9, negative 8, and 0. Let me make it zoom to see more clear. And the C, well, 5, negative 6 again, 2, 0, 3, negative 6. And now you replace the Z column by the right-hand side number, get 52, negative 42. Everyone follow me so far?
Yes, sir.
So far, so good, Professor.
So far, so good. Well, the rest is too long. I want to skip this. You type in one by one in GeoGebra, it's too long, I know. And you compute the determinant exactly the same we are doing before. And the answer is 30. The answer this guy is 150. The answer this guy is 120. And the answer this guy is 90. And the rest is just division. Kramer rule say x is equal dx over d. Y is equal dy over d. And c is equal dz over d. Entonces dx es 150 divided by 30 and 5. Okay, I get x equal 5. It's my first solution. The second is 120 over 30 and 4. Y is equal 4. And C by 30 is equal 3. And the solution for this system is the triplet order 5, 4, exactly like the option A in the handout. Any question?
No, sir.
Okay, sir. Okay, one question like that you expect in the test guy. Okay, remember, you solve it another way, no credit. You solve it by reduce echelon, you can, of course, in the real life, but no. In this question, they want you solve it using grammar. Okay. 16 question is exactly the same, but surprise. Do you see something new in this question? 16. 16 is, the system is x minus y, root 4c equal 4, equation 1, 2x plus c, that y is missing, equal 0, equation 2, and minus plus y minus 4c equal negative 8. Negative 8? Yeah, negative 8. Negative 8. Negative 8. Very well. The same organization. D, dx, dy, dc. But I want to compare first of all d. Is 1, negative 1, 4. 2, 0, 1. Negative 1, 1, and 4. And negative 4. So. Entonces I want, bueno, okay. Let's do it by Geogebra. This is similar idea in the previous example. But I want to compute this because when you compute this, you can stop. You can stop. The answer is 0. And it's obvious that the answer is 0. Because what happened with the row 1 and row 3? Do you think it's the same with the opposite sign? So it's, remember,
Just like the row number 3, the same equals 0.
Remember, the rule say, or the problem, or it's the same, twin brother, or family. Family is multiplication by factor. In this case, the factor is negative 1. That is the reason they change the sign, no? Because 1 times negative 1 is negative 1, negative 1 times negative 1 is positive 1, and positive 4 times negative 1 is negative 4. Therefore, this is one good proof. It also is 0 because they are proportional. Doesn't matter if it's positive factor or negative factor. So when the answer is 0, and you try, it doesn't matter if the answer here is 20, 30. Okay? By the way, it's not important. You see it's not applicable, the Kramer rule, because the Kramer rule divided by d. So x is equal dx divided by d. And division by 0 is impossible. So the answer is not applicable. Kramer rule. And that's it. We cannot use it. Maybe we can use in reduce row echelon form, or maybe we are doing the inverse symmetry. It's another way to solve this. Okay? Okay?
Yes, sir.
Okay.
Yes, sir.
Let's move on. The two problems about the application of the property for the determinant. 17 and 18 is the same idea. Apply the property, but In this case, you need to use your imagination, no? For example, 17. 17 is, so one determinant is given. Suppose it's given 17. One determinant is given, but using literal variable. UBW 1 minus 3 minus 1. And this is equal 38. This information is given. And they want you compute another que es similar, a family. Compute this is x, y, c minus x, ub, w minus u, no? And 1 minus 3 and minus 2. Okay? Question mark. This is the problem. Entonces, you remember something property. The property say when you perform under the determinant row operation or column operation, the value of the determinant doesn't change. It's unbelievable, but it's true. Column operation or row operation. And you see that something happened in between the column 1 and the column 2. So I try to manipulate, column 3, sorry. This is 3, this is 2. This is column 1, column 2, column 3. This is column 3. You manipulate not the giving. No, not the giving. Well, there are many ways to do, but I recommend you manipulate the new one in order to try to approach it. No. Should be exactly the same, the given information. So my proposal is doing the column operation. Column 3 plus column 1, addition, storage, and column 3. So we are doing this operation. So you adding the column 1, que es this, plus column 3, que es this, and storage the new information in the new column 3. This is the new column 3. So basically, the column 1 and the column 2 stay the same. I don't touch, doesn't change. And now I put the new information in the column 3 after the manipulation using this column operation. It basically is you adding this plus this plus this, and this plus this. So actually is c minus x plus x is c, because this and this is cancelled. W minus u plus u is just w, and negative 2 plus 1 is negative 1. Yeah, I get exactly the same determinant of the given information, and the answer is 38, because when you perform row operation, the value for the determinant doesn't change. Okay? Maybe in the test it's column operation or row operation. I don't know. So this is a little bit, this is the typical question that the student, I don't know why, failed. Okay, because you need to use a little bit your imagination. And no calculator, and no CAS, and no Geogebra is possible doing this because we use a literal variable. 18 is similar. Let me try 18. 18 is similar. Is XYZ UBW 1, negative 1, 3. This is given in this case a little bit different. 146 is the value for this. I need to compute. The new determinant. It's a little bit more complicated. It's look, is x plus 3. Y minus 3, C minus 9. Now, 3U, wow, minus 1, 3B minus 1, 3W minus plus 3. This is plus. And let me see. If it's minus plus. This is plus here, right? Plus. Plus. This no. Stay the same 1, negative 1, 3. It's 3 or 2? It's negative 2, no? Wait.
2.
No,
Looks like a 3.
I make a mistake. It's 3U minus 1. I see the 17 is 18. Okay, this is plus. This is plus also. This is 1, negative 1. And this is negative 3, no? And do it okay now? And
Yes,
this
sir.
is, wait. I copied wrong. 18 is 1, negative 1, and negative 3 here. Yes or no? I copied right or no? I copied right now?
Now, yes.
Yes.
Now it's right.
Okay, now it's right. Now it's right. Okay. I have no idea. I totally lost. It's complicated. Look like weird. Look like crazy. But no. Let's do it. Remember the row operation. So we apply 2 times row operation, no column operation. It's row operation. And also I apply another property in which you multiply any row or any column by a constant. Let me try. Hey, the noise. Again, the noise. Okay. Okay. Let me see. Erase this question sign. And I propose you the following row operation. This is using your imagination. Suppose negative 3, row 3, plus row 1, storage, and the new row 1. What is the idea? The idea is this and this. Row 1, row 2, row 3. I multiplication by negative 3. The negative 3, this negative 3 is a factor. Multiplication by each element in the row 3. So, and the first one is negative 3 times 1 is negative 3. And negative 3 plus row 1 is this expression. It's obvious que cancel out the 3 and stay only x, y, and z. Do you see that or no? And the rest, no? The rest stay the same. 3 minus 1, 3b plus 1, 3w plus 3. Because I only doing one row operation between row 3 and row 1, but affect the row 1. So the 1, negative 1, and negative. At least I did something. It was eliminate somehow these 3 and this 9. Okay, so I propose you another row operation because I want to eliminate this negative 1, positive 1, and 3. Is row 3 multiplication by nothing, by 1, positive 1, plus row 2, storage, and row 2. Then the row 1 stays the same, don't change. Row 3, no, stay the same. But row 2 change. Because when you adding this and this, it's obvious that this is cancelled. Stay then 3U, 3B, and 3W. Entonces, let me try to understand. When you apply row operations or column operation, the new determinant is equivalent. No equivalent. It's the same. It's the same number. Okay, it's the same number. It's the same number. Now, finally, I can see, wow, look at that, this 3. This 3 is a common factor. I factor out. This is the property number 4. We have X, Y, Z, UBW, 1, -1, and -3. And this guy is exactly the same of the original gets given. It was XYZ UBW 1, -1, -3. This value is 146. And 146 multiplication by 3 is 438. And it's the final answer that corresponds with the option. So basically, you apply the property number 5 2 times. The property 5. Again, property 5. And property 4. In the last. Any question? Entonces now in the test.
No, sir.
The test, you know, I don't know. Surprise. I don't know exactly what is the property, no? You're using your imagination, but you have time, no? Because I want to see. Okay. Image. Okay. Quintana Tons. Okay. Let me continue working. I don't know if we have time to finish or not. Okay. What is your opinion? Your opinion is, suppose worst scenario. Okay, I don't finish the review today. I suppose we have 20 minutes, no? I don't know. Suppose but I want to explain in detail, step by step. Okay, suppose we don't finish. You prefer, okay, I send to you and you start working in the park, you see, no? Now, third day, we finish the review. And remember, the next Tuesday. You prefer, or I keep the secret to the holiday? Yes. What means Jeremiah? What is yet? Option 1, option 2. Keep the secret or send to you today.
Send the test today because otherwise we'll only have 2 days to do it.
I suppose can you take advantage of this? Okay.
Yes, test today, please.
I say, well, don't worry. Okay, now, let's move on to the 19, no? 19, right? 19. 19 is a multiplication. Multiplication to matrix. Okay, I can save time if I, for example, I suppose you know how you put in Geogebra, no? 3, 6, -8. See, I skip the Geogebra part because it's the same repetition. It's stupid, no? It's a multiplication to matrix. This matrix and this matrix. If you want, let's do at least one. So multiplication. The first thing you should do in the multiplication of the matrix is checking the dimension. The dimension is 2 by 3. 2 row, 3 column in the first one. And the second is 3 by 3. It's a square. Because we have 3 row, 3 column. Entonces, matching perfectly this number and this number. The possibility to perform the multiplication is the number of the column in the first matching perfectly with the number of the row in the second. Okay? So, column of the first matching with the row of the second. And the new matrix that we expect, the dimension is this number and this number, 2 by 3. Okay? The answer is -11, 90, -14, 19, -38, and 50. Okay, well, but curiosity, let's do it in Geogebra. Why not? Why not? Why not? Why not? Why not? Why not? The only problem is the third day, we finished the review. I suppose in the first 15 minutes, we start new chapter, no? For the test 4. Yes or no? Are you agree or disagree with this idea?
Absolutely.
Okay.
Yes, sir.
Okay.
Go for it.
No problem. Okay. Okay. -9. You check and say make a mistake, I always make a mistake. 4, -2. This is my first matrix, no? And my
You didn't switch over to GeoGebra. We're still on the blackboard, Professor.
oh, sorry. Again, yeah, I make a mistake always. See, it's not switching the screen.
It's okay. I'm always leaving the mic on by mistake, so.
Okay. Switching here. Boom. Boom. Now, yes. Okay. So I typing my
Yes,
first.
sir.
Okay. My second matrix is -3. Oh, let me see. -3. Wait a second. Here. -3. 8. And -6. -3 again. Wow. Too many -3. 7 positive. -2. And -2. -3 again. Wow. I'm a -2. Okay. This is my 2 matrices. Immediately I create that matrices. Okay, I select here, boom, select my first, right click, create matrix, and the number of the matrix is M6. Okay, likewise, exactly the same. We create the second matrix. Right click, create matrix. I suppose it's a matrix M7, no? M7, yeah. Now I go to gas, and be careful, because remember the multiplication of the matrix is no commutative. So you make a mistake, you put M6 first, multiplication M7, and this matching perfectly the image. Otherwise, no, and you see mistake. Okay, so says M6 multiplication symbol, remember shift 8, like after, no? M7. Boom, final answer. -11, 90, -14, 19, -38, and 50. 2 by 3, 2 by 3. At the dimension for the new matrix. Do you understand very well this or no?
Yeah.
Super good. Super good. Okay. Come back again to the whiteboard. Yeah, I copy 2 new multiplication matrix. Okay, let me try. Okay. Suppose 20 and 21. Problem. It's the same. Multiplication to matrix. 20 and 21. 20 is 5, 7, 2, 3, -2, -8, -9, 9, 7. Multiplication 7, -5, -5, 3, 4, -3, 8, -3, and +2. Okay, and the first thing you should do is analyze. In this case, both are square matrix. 3 by 3. They are perfect coincidence with that number, and we expect a matrix 3 by 3. The answer. This 3 is that number, and this number is that number. I put both in Geogebra. I put M1, M2, M whatever, you know, the name, and press enter, and the answer is 72 minus 3, negative 42, negative 49, 1, and negative 25, 20, 60, and 32. Entonces, I encourage you to, when you study this verification, this answer, no? It's the same, but it's too long process, no? Consuming time, but it's no big deal. 21 is similar. Look at that. 21 is, suppose this matrix 2, negative 8, 1, 6, 0, 1, multiplication by another matrix, que is minus 3, 2, 1, and negative 1, 6, and 1. Don't forget, first of all, analyze dimension. This is 3 by 2. 3 row.
2 by 2.
3 by 2, both are identical. But look at that. Doesn't match the dimension.
Professor, aren't they 2 by 2? Not 3 by 2? You wrote
No.
2 by 2. 3 by 2.
Okay. This number.
Oh, no. Yes, I'm sorry.
Should be, no,
yes, sorry.
Must be equal. Must be the same. See, this condition not satisfied. The answer is not defined. It's impossible multiplication. Not defined. Not defined. It's impossible multiplication. Two matrices don't satisfy this condition. B should be, no, must be mandatory. Otherwise, no, it's undefined. So maybe in the test I put tricky example. Okay, it's impossible, and you need to analyze the dimension only like that, and you say, no, professor, no, impossible. Do the multiplication. This, no, hello, no, impossible. Okay, super, clear, crystal clear multiplication.
Yes, sir.
Super clear.
Okay, so let's go, move on to inverse matrix. I don't know if we have time to compute inverse matrix or not, or application, because the last part is application. Okay, suppose 22. 22, one matrix given, a matrix, suppose it is 4, negative 1, 5, and positive 1. Entonces, the equation is compute inverse. Es inverse matrix. Like that. Boom. Let's do it by hand. And let's do it in Geogebra, of course. Both ways. Okay, the formula. What is the formula? And there are a specific formula in 2 by 2. Relatively easy, not complicated. 3 by 3, we have formula, but it's very, very complicated. They need to explain another term and definition behind this, case horrible. So the 3 by 3, always we are using by Geogebra. 2 by 2, no. Well, either way. Suppose, what is the formula? The formula is, suppose A, B, C, and D. And the inverse is equal. It's equal. 1 over something, and something is AD, multiplication AD, minus BC. So you see, well, professor, this look like similar to the determinant. Why you don't explain before this? Because when you study inverse matrix, we don't know determinant. But basically, that part represents 1 over determinant of A. And this is valid for any dimension, 2 by 2, 3 by 3. The other thing is invalid only for 2 by 2 is. Okay, is you interchange A and D. You put D here and A here. And B and C stay in the same place, but you change the sign. This is the formula, guys. To compute by hand. Inverse matrix 2 by 2. Let's do it. in our specific example. In our specific example, suppose que we compute it first, the determinant of A. And it's easy, it's 4 times 1, in that direction is positive, no? In that direction is negative, but we have another negative. So the double negative becomes positive, is 5. And the answer is 9. So basically, in our specific example, the inverse matrix is 1 over 9. And the recipe is okay. You say que 4 and 1 interchange, 1 here, 4 here. And negative 1 and 5 stay the same, but opposite same. And leave it like that? No. No. Well, yeah, you can, but much better, more elegant is write the inverse matrix like that. Boom, boom, boom. Your multiplication, remember the multiplication, the matrix by scalar is totally different to the determinant. And the determinant you multiply by 1 row, 1 column. In this case, you multiply everything by 1 over 9. 1 over 9, 1 over 9, negative 5 over 9, and 4 over 9. And this is my final answer. My beautiful, elegant inverse matrix. Just in case, let's do it by curiosity in Geogebra. Okay, Geogebra. Do you understand the idea or no? Yes or no?
Yeah.
Yes, sir. No, yes, sir. Sir.
Okay.
They had a problem just like this on the homework, and I kept getting it wrong, even though I did it the inverse, but I forgot to multiply it by the dominant. So they determine it. I mean, so that's why. Okay, now I figured it out.
It's saying okay, no, but it's okay. We have 5 minutes, no? In 5 minutes, I have time to do how many problems? I don't know. No, it's okay. Let's move on to Geogebra. At least compute at least one inverse matrix. Okay, let me share the screen to Geogebra. Bang. Okay. You put it 2 by 2, get super easy. 2 by 2 is 4. 1. 5 and 1. No, negative 1, sorry. Negative 1 here. 5 and positive 1. Guys, one number can you change? One sign can you change? You are solving completely different problem. No good. Okay? Okay. Therefore, you select, and create the matrix. Right click, create matrix. And the name of this matrix is M8, I suppose, no? Okay. I go to gas, and you put invert. This is the weird spelling, invert. No inverse, invert. A ver, let me see, invert. Like that is okay? Yeah, invert. Invert, no inverse. The common sense, at least my common sense, indicate inverse. Pero es the syntaxis en Geogebra. M8. Press enter. Boom! Is the answer. 1 over 9, 1 over 9, negative 5 over 9, 4 over 9. Beautiful. Fantastic. No problema. Do you see?
Yes, sir. We see it. It's good.
Gracias.
Say again?
Yes, sir.
It's perfect. Thank you.
Pero the time is over, no. The time is not over. No? I have 5 minutes, no?
Yes, sir. You got about 4 minutes.
4 minutes. Our class is ending in 3:20, no? PM.
Yes, sir. 3:20.
Okay. Okay, guys. So let's do one couple more of the inverse matrix. An inverse matrix not always exists. Exists in 2 conditions. First of all, should be a square matrix. And also should be determined. Suppose the inverse matrix exists in 2 conditions.
Oh, we're still in Geogebra.
Yeah, sorry. Number 1, Okay, the inverse matrix exists in two conditions. Number one condition is square matrix. Okay, square matrix means 2 by 2, 3 by 3, impossible 3 by 4. And second one condition, determinant of A not 0. Because the determinant of A is 0 is division by 0, no? You see in the formula, no? This formula, inverse matrix is equal 1 over A, determinant of A, times 1 matrix. Entonces, the format in 2 by 2 was easy. Es DA, B negative, C negative. In 3 by 3, when M by M, the formula is super complicated. 1 over A, but this part stays the same. And we have another matrix very, very complicated. But I don't want to explain this now. Because you see the student can need to take college algebra to understand more clearly this. But you see que si determine S0, division by 0 undefined. Entonces this is when this situation is non-singular. Non-singular. This is technical name. Non-singular matrix is when the determinant is not 0, because when the determinant is 0, it's called singular. Don't ask me why this name is the mathematical name. Okay. Bueno, stop. 23, 24, 25, 26, 27, we covered last time. And last time, we start new chapter. Okay, this new chapter, in my opinion, is easy. In my opinion, you know. I want to say now, stay connected with me now, guys. I have another computer, the email ready to send to you the test. Let me know if you receive or no, because sometimes happen there are problems. See, we have no problem. You can leave. Okay, let me